From today, we are going to start the C programming. Before starting the C programming, we have to know that why this kind of thing we are using. What is a particular program? So some set of instructions, since we are talking with the computer, let's start it as a basic beginner, right? So I will be giving these classes as you are a totally beginner in that kind, right? So for a beginner, we have to know that when we are talking with the computer, right, we cannot talk in the language which we used to talk to our friends and family. We have to talk in such a language which is understandable to the computer also. The languages which the computer understands are known as programs. So these are basically some set of instructions which we give to the computer, and the computer understands each and every instruction and gives us the desired output. In case of communication, when we are communicating with our friend or any other person, what happens? We ask them, we give them some set of instructions, that is some queries. We are asking them something and they are giving us some output. Our talking is the input to the person, and whatever he is talking to us, returning us some answer, that is our output, desired output. If you are asking someone, how are you? Then that person is telling you, yes, I am fine. So this is the desired answer which you need, that how he is, well, whether he is fine or not. Same way, when we communicate with computers, there is an input which we are giving to the computer, that is the set of instructions, programs, which is basically based on some languages, right? Those languages which is understandable by your computer system. Done? So what are those kinds of languages? C, C++, Fortran, each and every these particular languages are used, and some special set of instructions are used there to communicate with the computer. Basically these are languages like we have Hindi, English, etc, etc. Same kind of these languages are also used for computer system, and these are having some set of programs, set of instructions which we give to the computer, that is the input to the computer, and the computer will give you some desired output, that is what is you want to know from the computer. Your query is the input, and the answer from the computer which is coming back, that is the output. That's all. That much is what is happening in programs. Done? Now, basically, what is a computer program? If you have to write in a description what is a computer program, then the definition will be: computer programs are written in any one language, C, C++, Fortran, etc, etc. So obviously computer programs, as I have already told you, that are written in some kind of languages, not in the language which we talk. It is the language which computer talks to us, that is C, C++, each and every thing which we will see afterwards also. These particular languages are used, and these languages have some certain set of instructions which we give to the computer and get the output. This set of instructions are your programs which we use in each and every language, right? So it has a set of instructions written in correct order to get the result, desired result. Like if you are going to talk to some person, you have to ask him. You just can't ask how you well or not. No. How are you? Well or not? This is the set of instructions, how the position of the words are going. So you have to give the position of the words in such a way so that the person whom you are talking with, he can easily understand your language and he can respond to you. Same way, when we are writing a computer program, we have to see that correct order is maintained. Each and every computer program should have a correct order. You will write the instructions and the computer will give you the answer, right? But those instructions should be always in a correct order. That's why it is called a sequence. In a particular sequence, the whole thing is written. When it is written in a particular sequence, then only you will get the desired result. Whatever instructions you are giving, each and every instructions. Why? The computer will just go through each and every instruction you are providing to the computer. Then after seeing those instructions, it will do some calculations. What kind of calculations? Not only arithmetic calculations, but it will do like this instruction, then I have to go to this instruction, then I have to go to this instruction. So it will follow those instructions step by step. Then only after following each and every step, at last it will give the desired result to you. It will return the desired result to you. So whenever you are writing the instructions, it is very much needed that it will be in a sequenced manner, that it will be in a correct order. So the order of the instructions written is very important. First of all, the language is important in which you are going to communicate with the computer. Second, the sequence or the correct order of those instructions is very much needed so that you can easily communicate with the computer, and the computer is also, it can also easily know what is going to happen, or it can easily see the instructions and give you the desired result, right? Now, the method of writing the instructions to solve the given problem is called programming. First of all, suppose we are going to make a addition of two numbers. If we are going to make an addition of two numbers, those two numbers, we need two numbers and an operand, that is your plus sign. So this operator sign and two operands on which we are going to do the operation, these things are needed. But to write, you just cannot write a plus b equals to what? No. You have to give the instruction in such a way that computer will understand a is a particular variable where I can put any value from my side. B is a particular variable where I can write some value. Now I have to add these two numbers and give a particular variable c which will hold the result, desired result, the summation of these two numbers, the addition of these two numbers. So basically what is happening here, that is the method of writing the instructions to solve the given problem. When you have the problem that you want to know this thing, or you have the particular problem, to get the result of that problem, what you have to do? You have to write some instructions in a correct order. This particular thing of writing the whole instructions in a correct order, in a sequential manner, in a correct order, and to give that thing to the computer, feed that thing to the computer, that is known as computer programming. Writing sequence whole instructions in a correct order. In why we are writing this thing? In order to get a desired result. So basically computer programs are set of instructions written in a correct order to get some desired result. That is called programming. That is your computer programming. Whatever computer language you use, anything, but that is what is the main thing. That is the instructions written in correct order. Done. Now programming techniques. You know about the programming now. You know what is programming. Now what are the programming techniques? There are basically two kinds of techniques what we use in case of computer programming. One is procedural, that is we follow some procedures to get the desired result, and one is object oriented programming, that is our Java, C++. So these kind of things have some object oriented programming. So object is related there, right? So procedural programming, C, what we will study in these classes, that is C, which is a procedural programming. A particular procedure is done there, a particular procedure is enabled there, okay? That you have to follow some step by step things, and you have to follow a particular structure, a particular procedure you have to follow there, right? So variables are identified. Here some variables, as I have already told you, if suppose a plus b I will need, so some variables are needed here. In C programming or in procedural programming, some variables are needed to identify. These variables will hold the values which you will provide at the time of getting the output. At that time you are just declaring the variables when writing the instructions or programming. After that, when you will run your program, that time you will get the result, desired result. That time you have to give feed the computer with your particular input. That input will be holded in those variables. Those variables are like containers where it will hold the values which you are giving as input, and this variable, it will contain the output. So basically variables are identified, which variable you are going to use for which purpose. So these variables are identified in case of procedural programming. Whenever you are writing procedural programming, so variables are needed. Instructions written using those variables in current sequence to get desired results. Now when you have the variables, now some instructions are written in correct order. This is the main thing. In procedural language, you have to maintain the correct order so that you can get the desired result. So while writing the procedural language, you have to first identify the variables. We will see while writing the programs, we will identify the variables with the help of some particular like int, float, or some particular keywords. These keywords will show you like int, float. Int means integer, float means some float values, and decimal values are also there, that is double values are also there. So these kind of values will be identified in case of computer variables. Again, characters are there, many things are there that we will study later, but basically some keywords are used to identify those variables, what kind of variables they are, whether they are characters or whether they are numbers, they are decimal numbers, what kind of characters are these particular variables. So to identify the variables is the first point. Second point, you have to write the set of instructions in a very correct order which is needed in case of, so using those variables, you have taken the variables, now you are writing the instructions in a correct order using those particular variables. These variables are needed while writing the particular program. So first of all, declaration that your program starts. Go-to statements, that is unconditional transfer from one part to another, is avoided by writing the statement sequence using many blocks, that is structured programming. These procedural languages are called, programming is called structured programming. Why? Some go-to keyword is there. These go-to statements, what they do, they just jump from one particular block to another block, from one part of the program. Suppose this is a flowchart. If you write this as a program, so from one part of the program, it just jumps to the other part. What happens there? This particular jumping is not allowed. Since it's a procedural language, what we do, we just use a particular procedure, use a particular sequence, so that the computer will give you the desired result without any error, right? So these kind of go-to statements, right? These kind of go-to statements, that is unconditional transfer of or unconditional jumping from one part to another part, is not allowed. In place of allowing this go-to, what we do, writing the statement sequence using many blocks, that is structured programming. We doesn't give this kind of go-to statement. What we do, we used to take some blocks, many blocks of instructions, that is many blocks, that is called structured programming. So some structure are maintained. We are taking many blocks of statements so that this go-to should not be used. Suddenly a jump from the one part to another part, what this does, it just makes your computer program more complicated. To not make the programs complicated, what we do, we just maintain a sequence, whether we are using many block of statements, but we will maintain a particular sequence so that each and every instruction is correctly identified by the computer, and it will not be so much time consuming, as well as it will not be very much complicated. So this is why we do not use this kind of go-to statements. Now commonly used to solve scientific and engineering problems using variables. Basically procedural language, what we do in procedural languages, we basically do what it is basically used in solving some engineering problems as well as your scientific problems by using some variables. So in engineering as well as in scientific problems also, these kind of procedural languages are used. Why these are used? Because it is having the variables, as well as it is maintaining a particular procedure or it's maintaining a particular sequence. So this is basically used here. So always whenever you are going for any kind of engineering problems or any kind of scientific problems, always procedural language will be used. That is procedural method, procedural programming techniques are used. Done. Now OOP, that is, what is OOP? OOP is object oriented programming, right? Object oriented programming. So object oriented programming is what? When we are talking about C++, this example, the basic example of this is C language. Okay, C language is the basic example of your procedural language. Now here what is the example? That is C++, Java, etc. Objects which have data related to a person or items are used. Here what we are using? There we were using some variables. Here we are using some objects which are related to some items or some person. These kind of objects are initialized or objects are used in kind of object oriented programming, that is your OOP. When you will study C++, afterwards in your more advanced classes, there you will see that how we initialize these objects and we do this kind of C++ programming, right? So basically here what is happening? The objects are used which are related to some person or some item. Now many functional blocks in programming. Here what happens? Here we were using some blocks of instructions. Here some functional blocks are used in case of OOP, that is your object oriented programming. Some functional blocks, that is some functional blocks are maintained. Here also we are maintaining some functional blocks in case of object oriented, but there are some variables were used, and here mainly we are working with the objects. Okay, now functional block contains instructions as procedural programming. Now here what happens? These functional blocks which we are using in case of OOP, those functional blocks are again having some instructions that are like procedural programming, right? So here also we are using procedural programming. These are also containing some instructions. These functional blocks are containing some instructions which is again having that your procedural programming. So what we understand, that procedural programming is the basic block. It is the basic stage which is needed whenever you are going to write any kind of programming in your computer science or in your IT, any background. Whenever it comes for writing any kind of computer programs, communicating with your computer, the basic building block is the procedural programming. Each and every place you will need this, because mainly what happens, procedures are needed. We have to maintain a sequence so that we can communicate very easily. It should be easy to you as well as it should be easy to your computer also. So these are also having this procedural programming. Ultimately you have to go there only. Commonly used to develop software packages. Here what happens, Java or C++, commonly these things are used for making the software packages. These software packages, these mainly whenever we are using this object oriented language, we just use this OOP to develop the software packages. There in C++, what we are doing, we can do the basic programming which is needed in our scientific as well as our engineering background. But whenever you are going to make some software packages, it's the advanced level of the programming. That is, basic level is your procedural language and the advanced level is your OOP, that is object oriented programming. There software packages, when you are going to develop, that time this OOP is needed. There your procedural languages will not be it cannot just make that one. You have to use this object oriented programming. Done. Now what we have to do when we are writing these instructions or writing the programming, whole programming, what happens? If you directly write the programming as a basic learner, if you directly you will write the programming, then what will happen? That some kind of errors can come, some kind of hazards, some kind of errors can develop there, because your first time you are writing this programming. So before writing the programs, what we do, basically we make a algorithm. Algorithm are what? These are step-by-step instructions which you will give to the computer. So before giving this particular step-by-step instructions to your computer, what we do, we basically write an algorithm. Algorithm are what? These are the blueprint of your program. Whatever thing you are going to write in your program, before writing the program, this algorithm is followed. Program is the set of instructions. These instructions you are going to write in a correct order to make the particular program, write the particular program. But before writing that program, what you have to do, you have to make a blueprint. Before making a particular building, what we do, first of all, we make a particular blueprint of the building. Then only step by step we start doing making the whole building. So first of all, you have to make a blueprint of your program. This blueprint is called your algorithm, as well as when you will give it a graphical representation, that will be your flowchart. So algorithms and flowcharts are very much needed while writing a program in your basic level. Also, if the program is so much lengthy or you have to write a big program where you don't want to have so many errors, at that time also these particular algorithms are needed. So while algorithm will be a subject, also a total whole subject while you will be on your higher classes in engineering or in other subjects. So this algorithm is a whole chapter there, a whole subject there. So algorithms are basically what? There are some steps of step-by-step instructions. You are writing the instructions in a correct order when you are giving this as a program. But before writing that program, some step-by-step sequence of that blueprint of that particular thing, particular program is made, where you will just write the basic lines, basic instructions which is needed while writing the whole program. In the program, you will maintain a sequence and you will write the whole instructions. But in the algorithm, each and everything is not written. Just the basic things, the main points of your program is written in case of algorithm, right? So basically, write programs without logical error. Without making any kind of logical error, if you want to write your program, at that time these particular algorithms are used. Algorithms are very much helpful for you if you want to write your program without having any kind of logical error. Any program you are going to write, if you want that particular program, that logical errors will not be there. So first step should be writing a particular algorithm. Any program which you are just confident, yes, I can write that program and it will have no errors, that you can write directly. But if you are having some kind of problem where you have to write a program but you don't know that whether some errors will encounter or not, so at that time, first of all, first step is you write a whole algorithm of your program, the main steps or main points of your program. Then just make the sequence and you have to write those particular steps or those particular things in a sequenced order, right? Design that particular program. First of all, design your algorithm, and then from that algorithm, when you will write the program, that will be having no logical errors. Basically, it helps in removing the logical errors. Now, rough writing showing steps involved in the programming. Algorithm is not a practical approach, or we are not going to show this algorithm anyway. It is just a rough writing of your rough blueprint of your whole thing, whole instructions or whole programming. So it is basically a rough writing and it is not wholly practical. It's just a rough writing of your whole program, so that you will not just, if you are writing directly or writing the programming, maybe you miss some points or maybe it will have some errors. But when you first of all you are making the algorithm, then what will happen? Logical errors are eliminated, as well as you will not miss any kind of point while writing the program. In small programs, you don't need the algorithm. You can easily write the program when you will know the whole C, whatever language, C language or anything, you will know. But when you don't know the particular program what we are going to write, at that time you can write this algorithm, which will be very helpful for you only, right? So this is the rough one. It is the step-by-step instructions required to solve any kind of problem. Any kind of problem you are taking as your particular aim of your program, at that time, first of all, you design the particular algorithm. When you will design the algorithm, it will be very easy for you to write. So it is a step-by-step instructions of step-by-step whatever things you are writing in a particular order in your program. That is a particular step-by-step instructions written in a rough manner, right? Now, flowchart. What is flowchart? Here you can see this is a particular algorithm. This is an algorithm, how we write a particular algorithm. But after writing this algorithm, you can make the flowchart also. Either you write the algorithm or make the flowchart, or you can have both. Flowchart is what? It will show you in a graphical manner. These are the instructions you write in a rough one. Now you will make the flowchart. How the whole instructions will flow. These are what? These are the instructions what I will give to my computer. These are the basically points which I need while making the program, right? But now what you have to see, here you have to make the flowchart, how this particular sequence is going to flow. That is your flowchart. Flowchart will show how the instructions is going to flow. Step by step written the instructions in a rough manner. This is that one. Now, how the particular instructions will go on. This thing is called flowchart. It will show you the flow of instructions. Here you can see that one. So this is the algorithm, rough step-by-step instructions written by you. Each and every point you will write here. Whatever are the main points which you need whenever writing this is your problem. Now, first of all, you are having the problem. From that problem, you have to understand what kind of instructions I have to give to my computer. Now you have to make a rough blueprint of those particular points. Step-by-step points, only the basic points. Then what you will do, you will see how the sequence will go. You will make the flowchart. Flowchart will show you how the sequence of these particular points will go on. From one sequence to another, from another to another, each and everything. Some else, if and else will be there, blocks will be there, some switch cases can be there, some loops can be there, anything can be there in your program. But you have to make that flowchart, that how the whole things are, how the instruction is going on, the flowing of the instruction, that thing you will doing with the help of your flowchart. Done. So blueprint, algorithm and flowchart, your graphical representation. These two things when you will do, you will obviously go and write a good programming. You will give a good programming which will be error free. Done. So these things are needed. Now flowchart is symbolic or diagrammatic representation of an algorithm. Same thing. Here what you have written, a graphical representation, or you can see a diagrammatic representation of, it's the diagram of your algorithm. This is the written instructions and it is the diagram of your algorithm. Whatever thing you are writing in the algorithm, just the diagram is called your flowchart. So instructions, rough instructions, algorithm, diagrammatic, that is your flowchart. Now shown by geometrical figures different operations, and by some geometrical figures you can see here. These geometrical figures will basically show you like this. This is another figure, this is another. So these geometrical signs will show you that what kind of instruction is going to be given to the computer. Each and every instruction is having a particular geometrical symbol. This symbol you will use while using or while writing the instructions whenever you need some kind of, suppose some kind of keyword or some kind of instruction. That instruction you have to follow that particular. You cannot just write for any particular instruction. You just cannot put any kind of diagrams, that is any kind of your geometrical figure. No. So each and every instruction have a particular geometrical figure which will be needed while writing the flowchart or making the flowchart, right? So different operations, these geometrical figures, what will they do? They will give you different kinds of operations. Then each and every geometrical figure will give you different kind of operations. So you have to first of all see which geometrical figure is giving you which kind of operation. So that you have to maintain. You have to remember that one. You just cannot put any kind of geometrical figure for any kind of instructions. No, you have to put those basic geometrical figures for a particular instruction. Right? So here, and some arrows are there. You can see these arrows. These arrows, what they do? They will show you the flow. That is the direction of your flow, how the flow is going on, the direction of your flow will be shown. That is there, how the instructions are going on. This will be shown by the help of these arrows. How the instructions is going. Like here you can see the whole instructions are going like this, so arrows are in this way. But here you can see that some condition is there, so the arrows are going in a particular way. So you have to maintain those arrows also, how your instruction is going on. So here you can understand what is the difference between these two. Here you are just writing the instructions step by step, and here what you have to do, here you have to see the flow of the instruction is already. Here you cannot find that what is the flow of your instruction. Here only the instructions are written. But to see the flow of instruction, this flowchart is needed. Now you understand why we need both of them, algorithm as well as flowchart, so that you can see the instructions as well as the flow of instruction is also followed. From which part of the particular program, which part of your program will be just done or which will be followed, for maintaining that one, this flowchart is needed. Now let's see the symbols. First of all, you can see the first symbol, that is this kind of symbol. So this is basically, it will show you start or stop. Only to start and stop, these symbols are needed. That is a oval shape, or you can, so it is a basically it's a oval shape which will show you the starting and beginning and ending of your program. Only for this purpose only, this particular shape is needed. You cannot use this shape for any other instruction. It will only show the starting of your program. Again, when this particular sign is visited, that means it is the end of the program. So basically it will show the beginning and the end of your flowchart. Beginning of your flowchart and end of your flowchart. Right? So this particular sign is written. Here you can see the beginning. I have used this one. And when again I will encounter this sign, means the stop. That means it is the end of my program. Here also beginning of my program and end of my program. So it will basically start and end your program. So whenever you are going to write a flowchart, first sign of your flowchart will be this one, and the last sign of your flowchart will be this one. This you can easily remember. Right? Now next is input or output. While giving some input output to your program, whatever the user is giving input to the computer, that is the input or the instructions which you are providing to the computer, that is your input, and the answer which you are getting from your computer, that is your output. So that particular sign will be like this. Okay, so this is the sign for your input or output. Here you can see in this case what is happening. It's for showing the sum and product of two numbers, and it's for finding the biggest of the two numbers. So here you can see these two signs are different. This is a box sign and it is a quadrilateral sign, or a just rectangular sign, until rectangle shape you can see here. So these particular signs are needed. This is rectangle and this is a parallelogram, right? So here you can see read AB here and again print. So these two are the instructions, input and output. When we are reading something, that is reading the values of A and B, that means what? You are giving the input to the computer. Read means what? Here in case of computer, read means, here also you can see read. Read means to give the input, right? And print means to get the output. These are the instructions. Read means the computer will read your particular input, whatever values you are giving to the computer, the queries you are giving to the computer, and output will be known as print. Each and every output will be given as print. Print F, your particular output will be printed on your console. That is your output, wherever you will see the output, that place, right? So this is the thing, that is read and print. So whenever you will encounter these things, I have to here, when I am writing the algorithm, here I have encountered read, that means these particular sign, and print means output. So here these two places I have put this sign. First of all, encountering starting and stopping this sign, and whenever you will find read or print, that place you will know that this sign will, particular sign will come, right? So this is the thing. Now third one is processing, arithmetic operator. While processing will be done, any kind of arithmetic operator, this rectangle is followed. This is for arithmetic operator, right? This is arithmetic operator. Now in these cases, where is the arithmetic operator? Sum. Here is the arithmetic operator, that is our plus. Again here the into sign, that's the asterisk sign which will show you the multiplication sign, right? So here whenever we are encountering these particular things, some arithmetic operator is there, you will have to give these particular symbols. Here also arithmetic operator is what? Here we are seeing the big A. That means I am telling that A is bigger than any other number. So that is also operator is happening there. So here also we are using this particular sign, big B, print B. When print is given, the sign will be like this. And when operation is going on, at that time, that is some processing is going on. Whenever some processing is going on, not only arithmetic, any kind of processing, so this processing sign is like this, a particular rectangle sign. There, whatever processing, what kind of operations you are going to do, whether arithmetic, any kind of operations, that time you will write this particular rectangle shape. That rectangle, inside that rectangle, you will write the whole operations which is going to happen in the particular sequence. So this is the sign of your operation, whatever processing is going on. This is for input output and this is for operation. Every time you have to remember these two signs, right? Now decision making. What is decision making? This is the sign of decision making. Okay, whenever decision will be given, an arrow will be there, either this or this. If yes, then this. If no, then this. So this is the symbol of decision. The decision will be written inside this particular symbol. So this symbol will show you what kind of decision. In case of if else block, when we will do that particular conditions, when conditions will be there, this kind of symbol will be encountered. So here where we are having that one, that is writing this thing, no decisions are there. But here we have some decisions. That is big A. If big is A, the bigger number is A, then it's okay. It will go to print big. But is big greater than B? I am assigning big A. That is A as the bigger one. I am assigning A to the big variable. Okay. Now, is big greater than B? Whatever value I am giving in A, I am putting in A, that value, is it bigger than B? B value, what I am putting two values, 20 and 30. So this is my A, this is my B. Now if I am putting here 20 and here 30, okay, so which one is bigger? If B is bigger, then B, assign B to B and it will print. Otherwise, it will print A only. Then stop. So some condition is going on. Whenever you're going for any condition, so this kind of sign is used. It will have two hands. One will show you positive, yes, one will negative. Then what next sequence will be done, next instruction will be followed, that will depend upon these particular two branches. One is for positive and one is for negative. So this is what is happening here in case of operations of these conditions. So if and else, basically it is used in if and else condition, because if and else will show you conditions, either this or this. So it is the main sign whenever you are going to write if and else. Okay. So in any program, while you are writing if and else, so this kind of sign will be used. This one. Here, arrow, if this, yes, if problem will be written here, whatever thing, and yes will be again here you will write something box, else this one. So this is the thing what is going to happen in case of conditions. Now next sign is your loop. Here loop condition I have not shown here. Next class I will show you the loop conditions also. In case of loop, this kind of sign is used. This kind of sign is used. This is a hexagon type sign. So this sign is used when we are going to write a loop. Loop is what? You will see in the other classes that what is loop. Basically loop is what? Whenever we are going to, loop is what? When some particular statement is, when these statements again and again it is going on, that time it will follow a loop. Okay, while loop is there, for loop is there, do while loop is there, different loop constructs are there when we use. When any particular instruction, it is fetched each and every time when some condition is given, but it will go on that particular instruction each and every time until that particular condition is followed or it is satisfied. That particular thing is known as loop. So whenever you will get some while loop, do while loop or for loop, so there this kind of sign will be used, right? This kind of sign is used for loop conditions. It is for loop condition. Fetching the same instruction again and again until a particular instruction or particular condition is satisfied. So that is loop. Okay. Now connector is there. In any case some connection, you are going to have some connection between any two programs. At that time this kind of small circle is used for showing the connection between two parts of your program. That is called a connector. This will called as a connector. Okay. So any kind of connection when you will going to be showing, that time you will show this kind of connector. Okay. Now decision making we have seen. Direction flow. Now what is coming is the direction flow. It is very important. How your flow of direction is going on. Like this, this or this. So these are the arrows which will show you flow of direction. Okay. Or direction flow. So these arrows are very much needed while you are going to show the how the flow. I will show you how this is happening here also. So flow of direction, how your direction is, but the whole sequence is going on, that direction is going to be shown by this arrows. So you have to see the arrow head where the head is pointing, that is the direction where the flow is going on, right? So arrowhead is very much needed and the arrows are very much needed while writing a flow chart. As the name suggests, it's a flow chart. So obviously flow of direction, of which direction the flow is going on, that is very much important. So the arrowhead will show you where the flow is going on, the direction of the flow, right? So this is the thing, whole thing which are needed in case of writing a flow chart. Now we are having two problems here. Let's see how this algorithm and this flow chart is basically made, right? So this is the first problem which we have, that is the flow chart to show the sum and product of two numbers. Suppose here we are taking two numbers, that is our A and B. Okay, A and B, these are the two numbers. Now these are my variables which I will assign. Okay, this variable A and B are my variables which I will assign integer value. Since I am doing a sum, here first of all I will take a integer. You can take float, decimal, anything, double, anything, but here we will take a integer as int. Okay, so first sentence will be what? Int A B, right? Why int A B? Here we are going to just put the variables, put the values which you are going to do the summation and the multiplication. So these two values you have to initialize. Initializing means you have to declare those particular variables. Why? These variables will be the container where at the time of giving the input, when you will run the program, these particular instructions will be followed or fetched by your computer, and it will give you the particular output. So these will, at that time, these particular variables will hold the value which you will provide to the computer, which numbers you want to get the sum and multiplication of. So that time these variables will be needed. So first of all, the main thing is you have to initialize the variables. Then now here we can see algorithm read A and B. So here first statement is what? Read A and B. Right? First instruction is int AB, that is I am reading the values of A and B. Whenever you are going to read the values of A and B, it will give printf. We will see when we will write the program, A value and B value. It will declare that one. Okay. A sequence is there when we will write the program. I am just showing you a rough sketch of how we will write. We will first of all read the values of A and B. Then after reading these values, so whenever you are going to read the values, first of all, the starting of your algorithm, you have to make the flowchart start. Then this symbol, oval symbol and start. That means my starting of program is, beginning of program is present. Now after that you can see the flow of the arrow. It is coming down. That means after start, next step what it will be? Read A and B. That means I have to fetch the values A and B. Two variables are needed, two numbers are needed to get the summation and multiplication. Without two numbers you cannot, more than two numbers, here we are going to do for 2. If you are going to get for 3, you have to declare 3 variables. For 4 variables. Multiplication of two numbers we are writing here. So we are making the sum of two numbers also. Okay. So here, if you want to do more than 2 numbers, then you can give C. But multiplication is for 2 numbers only. Now, product for 2 numbers. First of all, you are going to read the value. Then, after reading, you have to do the summation. We are doing the summation of the 2 numbers. Right? That is A plus B. So, here the instruction is what? Summation. That is some operator. Here the reading value, that is input, is given. So, this kind of value is there. Here summation is done, so this particular symbol will be used. Here sum A plus B. Sum A plus B means you have to know that when you are having sum A plus B means it have a meaning also. What meaning? Sum A plus B here means what? This sum will contain the summation of these two numbers. The sum of these two numbers will be held here in your container. Sum. Right? So obviously you have to initialize again int sum equals to 0. Sum equals to 0, but why we are writing this one? So that summation, first of all, when we are going to give some value to the summation, that will be 0 because no value is there, present there. You can write sum also. So here this sum will contain whatever value will be provided by this A plus B. Then, so sum equals to A plus B. That means here sum equals to A plus B. Again a sum variable should be initialized where A plus B value will be present. Right? Now product, in case of product also, again you will have to initialize that one. Here this product will have the value of multiplicative value, that is the multiplication, whatever value will get, that will be in your product. So here again this particular have some arithmetic operator, so you will have to give this symbol. You can see the flow of your, whatever direction of your flow is straight here, one by one. Then now print sum and product. Here we are getting the output. Print sum and product. Now whatever sum and product you have got, two things was the aim, to get the sum and product. We have done the summation, the multiplication. Now you are going to get the sum and product. So here again this kind of sign will be there, the parallelogram sign. So it will show you the, give you the particular output. So this is my input in this case, this is my output in this case, and these are the operators. Okay, so these are the operating, that is the processing statements whenever you are having the processing statements, at that times the sign will be simple rectangle. So the whole process is done, then stop means this. This is the end of my flowchart. This is the way how we write a foolproof program. Then a foolproof algorithm and flowchart. After writing this, from this how will we write the program, that we will see in next class. From algorithm how we are to write the program. Then now in second case, I have again given an example where you can see how condition is done or how conditional operator is done or it is made in a flowchart. So first of all, again starting symbol, starting one, then again initialization of variables, int a, b, big will be one variable where you will be getting the value, which one is the biggest one. So first of all, a, b and big, since it will be having the value, a value, b value, then comparing whatever value will be the biggest, it will come to this container, right? So first of all, read, starting symbol, that means I am starting the program from beginning of my program. Then what? Read AB. Read AB means I am reading these two values, getting the values as my input. So this is the input instruction. Obviously it will be a parallelogram, right? Then now afterwards, big equals to A. Now big is my container where I am putting the value A. Big equals to A. Now my big container is having, suppose if I am taking A as 20 and B as 30. So in this condition, first of all, this big will contain 20 since it is my A's value. Then how I am going to compare? First of all, I have to see if two things are there in my hands. To compare which one is the biggest, I have to, first of all, I have to think this one is the biggest one. Then I have to compare this with the size of that particular thing. Then only I can know that which one is the biggest. To compare those two things. Okay. So first of all, computer, how it will follow your instruction. First of all, it will assign these three variables, A, B and big. These are the three containers. Here A, B and big. I am putting here 20, 30. And now first case I will assign big equals to A. My big container will have the value A, that is 20. Then afterwards, next is if big is greater than B. Now some condition is coming. That's whether big I have assigned A, if big is greater than B, right? So what is the value of big now? 20. Greater than 30? Is it, if 20 is greater than 30, then write big. Big equals to B. That is, big will be equals to, big is greater than B, then big will be, if greater than B, suppose my big is 20 and it is greater than B, no. So if no, then it's okay. We will write that one. Whatever value is greater, we will write that one. But if it is greater, then if no, then 30. If yes, then 20. So here you have to follow the instruction. If B is greater than, big is greater than B, that is A is greater, then you will write here, assign here big equals to A. Print again if big is greater than B, no, big is greater, then you will write big. If B is greater, then you will write B. Understood? That here what is happening, this particular thing is going to show you the condition. See like this. This is the condition. So what it is showing? Big is equals to A. Done. Now is B greater than B? Whatever value is there in the big, in here we have already assigned A in B container. So obviously here what is the value? If big is greater than b, here and here. Now write like this. If the value is big is greater, okay, then yes, then you will write here big. That is, whatever value is there in the big, you will write here. But if b is greater, then you have to write here, you will assign big as b. If no, then what was there? Same thing will happen. So it will come here. If yes, that yes, big is greater, that means what? My a is greater. So whatever I have assigned previously, that is the answer only. So obviously it will show me, yes, I will just print this big. I will print the value of big. But if it is not assigned, if b is greater, then what we will do, we will assign b in big. We will remove a and assign b in big. Then what will happen? We will just put this here and print big. Then, so here is the sequence what is happening here. Is big is equals to b? If no, it will come here. If yes, then it will come here. So this is the sequence what is happening. Each and every place, whenever you will have the condition, you have to write that in such a way that one hand will show you the positive and one hand will show you the negative one. Again see, if big is equals to suppose 40 and b, we are taking a is equals to 40 and b is equals to 30. Then big equals to a, it is taking the value of 40, big is taking the value of 40 now, that is a. Now here is checking whether 40 is greater than 30 or not. Right? That is big, means 40 is greater than value of b, that is 30 or not. No, it's not possible, it is not big. Okay, so if no, then it's okay, it is coming here. If yes, then you write big equals to b, that yes, my big is b is greater. But if no, then like this. Then so you have to see each and every time. If my a value is bigger, then yes, this one a value is bigger, it will just print the value. But if b is bigger, that means it will go here, it will change the number. The container will change the number as b. If a is greater, then it is having the value of a. Now also it is having the value of a first of all. Then it will just print the value. But if b is greater, then what will happen? It will go here and it will just change the value of b and then print the value. This is what is there in condition. You have to, every time you have to see how the condition is changing. Like that, you will have the result, particular result. Then you will print the big. So here also you can see in case of algorithm also, big is assigned as a. Then if big is greater than b, then big you will assign b. That is b value. If b is greater than big, then you will assign big value as b, and then you will print which one is bigger one. Then only this one. If not, then you will directly print here. But in case of algorithm, it is not clear that how the sequence of flow is going on. But when you are going to write the whole flow chart, the sequence will be clear. Here you have the idea only. In this case of flow chart, you have the idea only. But in case of this flow algorithm, you have the idea. But how the flow will go, you have no idea. But in flow chart, you will have the idea how the flow is going on. Okay, so from here to here, you can see that this is the starting, this is the input. Here is the operation or the processing is done. Right. So again, we will see the processing whenever processing is done. So these kind of statements are given. Like this. Here, these kind of statements are given. If B is greater than B, if B is greater, what will happen? Yes, B is greater. Then what we will do? We will write here, assign a value big equals to B. Right? But if not, that is B is not greater, then already we have put big as A. We will just print the value. When printing the value, that means my output. So, print the value of big. If this one happened, then also we will print the value. We have to print the value. So, while printing the value, we will just see this is assigned, just print the value. If this condition is false, just print the value since it is already assigned. But if this condition is true, then you have to change the value of your big container and then you will write the particular thing. Here you will get the output. Then just stop by this symbol. So this is what is happening in your whole flowchart. So to see these branches is very important. Which one will be which value, it is very important. Okay, so here it is how we write the flowchart from the algorithm. Now from algorithm and flowchart, how you will write the program, that we will do in next class. It's a very lengthy video for today since it's an instruction class or the introduction class. Next class we will start with the programs, because C programming is basically wholly a program based subject. Theoretical portion is there for understanding the function of each and everything, but basically the main thing is practical here, that is your programs here. I will show you each and every program of different chapters one by one so that you can understand it fully. To get more classes of this C programming for the beginners, please follow my channel, subscribe it and like it. Till then, take care and goodbye.